Okay, oops.
Two scientists published the most complete picture of the ocean floor that had ever been created, revolutionizing our understanding of the Earth. Named the Tharp-Heezen map after its collaborators, this illustration was produced using sonar and measurements of the water's depth. It revealed, for the first time, a complex network of underwater mountains and ridges, and provided key evidence that supported the emerging geological theory of plate tectonics.
Let me see if I can get this to be larger. I don't know why it doesn't have like a full screen option. Does anybody know how I might find that?
No.
Show controls?
It probably isn't.
It probably isn't. I guess we'll have to do it this way.
The Earth's solid outer shell, the lithosphere, is broken into plates. These plates shift and slide over the asthenosphere, the molten upper portion of the mantle. Oceanic and continental plates meet and interact at boundaries that crisscross our planet. Because 71% of the Earth is covered with water, the majority of boundaries are found on the seafloor. When two oceanic plates tear apart from each other at a divergent plate boundary, the space between the divergent plates fills with magma that hardens when exposed to cold seawater. Over millions of years, this process has built chains of underwater volcanoes and rift valleys called the mid-ocean ridge.
Oh, interesting.
When the plates move apart, they rip open the Earth. The mid-ocean ridge, which runs around our planet like the seam on a baseball, is where the Earth creates its outer skin. And as these plates move, they're in a synchronized ballet.
There are few places on Earth where the mid-oceanic ridge rises out of the ocean, giving us a chance to see this phenomenon on dry land. Iceland is one of them. The island of Iceland was once an underwater section of the mid-ocean ridge. Over millions of years, it was pushed up above sea level by a giant volcanic hotspot. Here, we can see a divergent plate boundary, a stretch of the mid-Atlantic ridge where the North American and Eurasian plates are spreading.
So that's what you write down. Did you catch that one? Did you have that one written down?
Divergent plate boundary, that's one of them. Write it down.
Dr. Bob Ballard has come to this unique spot where crystal clear glacier water
What is the
fills a section of the mid-ocean ridge.
Okay. If you have not yet written it down, I see it. Divergent plate boundary, that's one of them. That's one of your boundaries. Write it down. And also, while you're here, write down what it is. Go ahead and do that real quick. Use your pencil. Watching a video does not mean you turn your brain off. Watching a video means that you're actually learning from it. I don't know why it won't let me go, though. It's like they made a poor choice in the design of this. You have it written down? Divergent plate boundary and what it is? Yes or no? Yes? Great.
That has been raised above sea level.
Boy, that's truly amazing. I'm literally at the boundary of creation in Iceland. On my left is the North American plate right here. I can put my hand on North American. I can reach over here and put my hand on the Eurasian plate. And this is the very spot where the Earth is spreading open, about an inch a year, about your height in your lifetime.
When two plates are spreading apart in one section of the world, other plates are moving toward each other in a different area, forming a convergent plate boundary. At these kinds of plate boundaries, one plate can slide underneath the other in a process called subduction. Or the two plates can crash into each other, creating a mountain range. The Himalayan mountains formed this way when two continental plates collided. On the Mediterranean island of Cyprus, we find an example of a convergent plate boundary that was raised above sea level 90 million years ago as the African and Eurasian plates collided. Dr. Ballard has come to explore this unique part of the mid-ocean ridge in the light of day.
I'm standing on what was an ancient ocean floor, would have been thousands of feet beneath the sea, and what we're looking at is an area where the subsequent collision of these great plates, the African plate and the Eurasian plate, then began to force this part of the ocean floor up to where it is today.
This upward movement revealed ancient volcanic activity that had taken place on the ocean floor.
If you look into that upper section, you'll see these round-looking objects, and those are actually what we call the pillow lavas, because as the lava comes out, and no sooner does it come out, it's quenched. And then it expands and continues to quench and forms these pillow-shaped forms, and then it'll pop out, form another one, pop out, form another one. So you can literally see all these different areas in which the molten lava actually expanded out and then cooled.
The study of plate tectonics, from the tallest mountains to the bottom of the ocean, helps scientists understand the extraordinary processes that continually shape and reshape our planet, sculpting majestic landscapes, causing earthquakes and volcanoes, and supplying natural resources.
All right. How are we doing? How many did you get? Got 2. You got all 3? All right, let's write down the ones we know. So type number 1 or boundary number 1, what was it? Divergent. And what is a divergent plate boundary? What does that mean? Yep, the plates are going to pull apart. Yep. And what happens at a divergent plate boundary? Do you get new crust or do you get rid of crust? Is crust created or destroyed, I guess is the question I'm asking. New crust, right? Crust is created. Type number 2. What was the second kind? Convergent, yeah. And what happens at a convergent plate boundary? They spread apart? So where do they spread apart? Do they spread apart at the convergent boundaries? Together. They spread apart at the divergent boundary, right? So the divergent boundary is where to diverge means that you separate, right? Okay. At the convergent boundary, what happens to the plates? They push together, yes. They push together, and in doing so, what happens to some of the crust? It goes what? I can barely hear you. Can you speak just a little bit louder?
Like it goes up.
Some of it goes up. Some of it goes down, right? So the stuff that goes up makes something like maybe a mountain, and the stuff that goes down into the mantle. And so some of the crust is being destroyed, right? Subsumed. Yeah. Do you remember how much they said the crust was, how much like that divergent plate boundary was growing every year? An inch, right? And if the divergent boundary is creating crust at about an inch a year, and the convergent boundary isn't consuming or destroying crust that fast, that means that our Earth would just be getting bigger and bigger. You with me there? Which doesn't make sense. So this convergent boundary definitely has to be destroying crust as well in order for our Earth to stay about the same size. All right. And there is a third type of boundary that I don't think that they actually talked about in that video. Does anybody know what it is? Yeah.
A transform boundary.
It is. It's a transform. A transform boundary. So we're going to spend some more time with this later today, but I just want to make sure this makes sense. So a divergent boundary means, oops, I was going to do this backwards, that the two plates separate. A convergent boundary means that the two plates come together. What happens at a transform boundary? What's that?
Is it one goes the other way, one goes the other?
Yeah. So they go like this. Yeah. They go across, like they go next to each other. So one goes like this, and the other one goes like this, and so they rub against each other like that. Yeah. We'll spend some more time with transform boundaries today, so you'll kind of understand them after our conversation or after your reading today. Okay? 1, 2, 3. Those are big things to know, important things to know. Questions there? Okay. So let me explain what's going to happen for the rest of the day, and then I'm just going to let you get started. Okay? Can I move this? Is that okay? Does everybody got what they need from here?
Yeah.
Okay. So in just a minute, I'm going to hand your quizzes back, and we'll talk about that. After that, some of you, I think, needed to finish the map reading. Is that correct? Okay. So that is your number one priority for today, is that if you and your table need to get a map and finish the map reading, that's the questions 1 through 10 on that sheet. You'll do that first. Okay. If you're finished with that, then the next thing for you to do is the video and questions that are on the back. So you'll get your Chromebook out. These two things are both kind of individual activities. The map reading and group work is going to be with your table. The last two are individual. So you're going to watch a video and answer some questions. And then the third thing that we're going to do today is it's actually the second half of the next activity, but because of logistics with trying to get equipment, we're just going to do the second half first, which means that tomorrow we'll do the beginning. It's this page here. I went downstairs to make copies. I think I saw a couple of you on the stairs as I was going down, and the copy machines one was had a line of like 4 people, and the other one was not working. So I'm going to put this up on Canvas so that you have access to it, and it's a reading from the textbook. So there's a reading for you to do, and then some questions to answer. Does that make sense? So those are the 3 things that you need to do today. Okay, that should keep you very full and busy throughout the day. Okay, if you are working hard all day, then you will not have homework tonight. Okay, so I'm just going to kind of like leave that out there. So that'll be our plan for the day. I will put the reading and the questions up on Canvas while you guys are finishing this. This link is already up on Canvas, so you got that if you're done with the maps. Okay, I'm going to stop.